Okay, section 3.6, and we want to look at drawing f and f prime from f double prime. Okay, so, well, if you've made it through the first two, really then going from f double prime to f prime, that's just like going from f prime to f, so hopefully you've done that and tried that some. And then, of course, once you have f prime and going to f, well, you've done that before, so, hopefully it's not too bad. Well, let's just start with, suppose f double prime looks like that, is just a straight line. Then f prime, well, f double prime is its derivative, so f prime had a critical number here. This is a second order critical number. And the slopes of f prime were negative over here to the left of that critical number, and they were positive over here to the right of that critical number. And so I could draw it, it was decreasing and then increasing and had a minimum right there. So there's f prime. And then if I drew it this way, now this is the thing, you can get some different answers, so we'll do this a couple of times and we'll see how, if depending on where I draw f prime, I could get some different answers, slightly different answers. So here's f prime. Now to draw f, we do the same thing. Well, when I draw f, see, all these slopes were positive for f. So f is increasing the whole time. And however, what we know is that, well, it was increasing really steeply, but then not as steeply because the derivative is smaller down here than it is up here. And then, so it was steep and then not as steep, but still positive slopes. And then it got steeper again. And so I could draw something like that down here where it's out of the way. So steep, less steep, and then more steep again. And there's an inflection point, right? And f double prime was 0. So, yep, concave down, f double prime was negative. Concave up, f double prime was positive. And so there's f. Now I'm going to start with that same f double prime and show that you can get different answers. Okay, so there's that same f double prime. There's that same, right, same critical number. And so this time, though, I'm going to draw the f prime, instead of up above the x-axis, I'm going to draw it like that. So there's f prime. But now you see, when I draw f prime, here is a critical, first order critical number. There's a first order critical number. And f prime is positive here, negative there. So that means this is going to be a local max for f. And this one's going to be a local min because, well, it's negative here and positive there. And so now, I can draw, say, something for f that looks maybe, like this. And then there's the, right in here is the inflection point. It comes down and then increases again. Okay, so there's f. Has a nice kind of cubic look to it. But you see, that's very different than this one. And not way, way different. I mean, the concavity is the same. It's concave down. and then it's concave up, just like up here it was concave down and then concave up. And, but in this case, I had a local max, or a relative max, and a relative min here. And the difference was that when I drew f prime, the first time I happened to draw f prime and it was always up here above the x-axis. So the derivative of f was always positive. So f had to always be increasing. But when I slid it down here, now the derivative of f is positive, and then negative, and then positive again. And so positive, it's increasing, and then it was negative, it was decreasing, and then it was positive again. And so we ended up with these relative max and min. And so when you have these two functions that are beyond f double prime like that, so you start with a derivative and you go up one derivative, but then you go up another derivative, you can actually you can get some very different answers in some sense, right? So the first derivative part, the f prime, well, yeah, I drew it lower this time, but it was pretty much, it was the same shape. But because I drew f prime a little differently, I would say that f was a different shape in the second example than the first example. Okay, so you can get a lot more variability in your function f if you are starting with f double prime. Okay, because you can get some variability from f prime, and then that will cause even more variability in the function f itself. Okay, so it's the same basic idea, but in a lot of ways, you wouldn't expect necessarily two people to come up with the same final answer for that last function f because of any changes in positive or negative of f prime will have big changes in f. Okay, so there is drawing, there's a couple examples, in some sense the same example, but a couple of examples in going from f double prime all the way back to the original function f and sketching that.